is differentiable. Okay, that means that the f is smooth and continuous, means that f prime, if it's differentiable, it means that f prime is continuous. Okay, not necessarily smooth, but it's definitely continuous. It says it's increasing for all numbers of x, so it means that the f prime is positive, and the graph of f has exactly one point of inflection. Okay, of the following, which could be a graph of f prime. So there we're being asked to find f prime. So if f is increasing for all real numbers of x, all the values of f prime must be positive. So we need to eliminate, okay, there's some negative f prime values. Okay, so that we can eliminate that. There's some negative f prime values there, so we can eliminate that. There's some negative f prime values there, so we can eliminate that. So these cannot be increasing for the entire region. So we're left with just A and E. Okay, so I'll use the black was showing the increasing. So let's change colors here. The graph has exactly one point of inflection. Well, one point of inflection means that the second derivative, the slope, it means the second derivative must change, okay, from positive to negative, or the slope of the slope must go from positive to negative or negative to positive. So if you take a look here, this is my f prime graph, and the slope here is negative. Okay, that means that f double prime is equal to negative. Okay, here the slope is positive. So f double prime, or the slope, since this is a slope function, this is the slope of the slope, it's going to positive. So I've got one change of concavity there. So this looks like it's the right one. Okay, just check here. Well, why wouldn't this one be the case? Well, here I have f prime, the derivative of f prime. So f double prime, that's positive here. Here, f double prime, or the derivative of f prime, is negative. So that means I have an inflection point there where it changes from positive to negative. But I also have another one here when I go from a negative second derivative to a positive second derivative. So this one actually has two inflection points. Okay, so although, I'll just highlight that. Okay, those inflection points happen where there's a turning point on the derivative. So there's two inflections, so we can eliminate this one based on that. So based on the fact that it has one inflection point, we can say that answer must be